All right, what are we working on here, guys?
Cylinder 1.
The Bang Bronco.
The Bang Bronco. What year is this? It might forever be known as that. Randy had asked for what?
It's the O.J. Simpson Bronco.
Oh, that's where you were getting from that. I missed the reference. No, seriously, what are we working on? What year is this?
87.
87 Ford Bronco with a 5.0, right?
Yep.
All right, symptoms of this vehicle is a misfire. When we drive it, under load, wide open throttle runs great. And light throttle, it's pretty severe miss, right? Wouldn't you say, Jess and Ryan, you guys went for a ride with me. When we were driving it, it felt like more than just a single cylinder, didn't it?
Yeah.
Okay. Yeah, the whole thing was shaking, but heavy load, it was pretty decent. A lot of problems we've been fixing on this thing along the way. The map sensor was faulty, and the distributor was missing the spout connector, and timing was off, and all kinds of stuff. But what we did, I'm going to try to recreate. I had everyone hook up the secondary ignition so we could identify what cylinder was misfiring, and that's what I'm going to show you next. So we're hooking up to the system. We have a trigger lead connected to the number 1, and we have this, where is that SAI 2000? This almost obsolete tool now because of most systems don't have plug wires, but that's what we're using to grab the secondary. And yeah, let's start this. Okay, so just looking at secondary in a parade pattern, we have this all set up already, and we see our cylinders at the bottom, 1, 5, 4, 2, and I want you guys to focus on the number 2 here. Let's just kind of watch this for a second. I want you to pay attention to the spark line on the number 2 when we raise our RPM. So go ahead and raise it just a little bit. See it kind of disappearing on us. And we were seeing the same thing with the other cylinders too when we did a couple snap throttle tests. We actually saw it yesterday. All right, cool, let it idle. You see that line kind of totally disappear. Sometimes you can have mistriggering when you're doing secondary, but in our case yesterday, didn't we see like 4 cylinders doing the same thing, guys? Yeah. Weren't we seeing it on random different cylinders, right? Cylinder 6, figures that cooling fan would turn on the highest speed while I'm talking. But anyway, our focus is on the number 2. And why is this signal disappearing? And then why is that spark line changing so much? So do that one more time so we can see it. Just raising the RPM. That spark line totally disappearing. Okay, cool. Good. Kill it. All right, so the next test that I had them do is I had them switch the spark plug with the number 1 and the number 2, and then we redid this test. And what did we find? We found the same exact thing, didn't we? Yep. And then I had them swap the wires for the number 1 and the number 2, and again we had the same exact thing. So now we start focusing on the cap and rotor. Let me show you what we found. All right, so what test I'm doing now is I'm using a spark tester that's actually in line to the spark plug wire. And I don't remember, did we go to ground or did I go to the spark plug last time I did this? I went to ground.
Yeah, you went to ground.
Okay, cool. I like to go to the plug sometimes because I want to see the spark plug firing in a compression environment, and it's actually more accurate, but in this case this was good enough to show us what we wanted to see. And what our question was with the spark, we're going to do a visual on the spark, is I wanted to know if I was actually losing the spark visually because our scope kept dropping that cylinder out almost like a mistrigger. So that's what our intent was. Go ahead, you can turn that light off so we can see this better, and go ahead and start it up and we'll watch the spark. So number 2 going to ground. Hold the RPM up a little bit. We saw the spark missing there a couple times. Hold it steady. You notice sometimes that spark is really fat. Sometimes the spark is really skinny. And then at other times it's actually completely disappearing. Okay. Alright, shut it off, Mitch. Now the only downside of this, guys, is the camera's frequency may not match what we saw live. I'm hoping that I was able to show that. When I go back and review this in the edit, I might find that what we saw live is not what I'm seeing on the camera. You'll be able to hear the cracking of the spark, but it won't be timed exactly with the frequency of my camera. I'm using my older camera. I maybe should have used my newer one to catch it. But what we saw again was an inconsistent spark. Visually, we saw the spark line being fat and heavy, and then we saw it being very skinny and light, and then at other times we saw it dropping out completely. So
should we do the other wire then, if that's the case?
the other wire.
Because the other one, you can noticeably hear it too.
You mean the coil wire one that I showed before?
No, on the other spark plug too. Because the other one, remember when we did it, you could noticeably hear it, and it was a thicker line in there.
Yeah, no, that was actually the coil wire.
Oh, that was?
Yeah. We can compare it to another cylinder.
Okay.
We didn't do that previously, but we can do that now. Let me just say this before we go further. This screams a cap and rotor problem, right? Yep. We have garbage coming out of this cap and rotor. It's not a plug or wire problem. And so what we did next is we checked the coil to see what the coil looked like. And I guess I can show that test too. It would be helpful, Alex, to show another plug to see if it's affecting another cylinder the same way. Let's do that because we didn't do that yet. All right, same check on the number 1 cylinder. Go ahead and kill that light so we can watch this. And go ahead and start it. You can actually hear the difference in this spark. This one's very, very audible, cracking every time it fires. And so far, I don't know about you guys, but I have not seen a drop in that at all. It's been consistent every single time. So let's just watch it for a second. Go ahead and raise your RPM. Nice and heavy, right? Nice and thick, firing every single time. Awesome. Okay, good enough. Go ahead and shut that off. Turn that light back on. So let me ask you guys something. Being that we have the same coil, which is over there, we have the same ignition coil that is firing every single cylinder, what does that number 1 test tell us about the coil?
That's good.
That it's good, right? And number 2 is crapping out on us. So that almost guarantees the cap and rotor problem, doesn't it?
Yep.
Right? All right, but it doesn't. I wouldn't be filming this if it was just a cap and rotor problem. So what I want to show you guys now is the primary of this ignition coil. Let's take a look at it and then we'll talk about it. So we have our amp probe already connected. We're going to read the current flow into the primary. Let me get a shot over there. Just want you to see the setup of how I'm connected. Just have the jaws of my amp clamp connected to one of the primary ignition wires. Whether that's feed or control is not important. We can go to either one for amperage. Okay? And remember that we're measuring the primary of the coil, not the secondary for this test. All right, guys, what I want you to focus on, we'll change this to a 10 amp. I want you to focus right away at how narrow some of these charge events are and how fat some of them are. And what we'll do is we'll just pause that and go ahead and shut that off. And I will scroll out just a little bit. And if you look at this, you'll notice dwell time. So that's our charge time of our coil. So where the coil turns on, the increase in the ramp is where we turn it on, and then the falling of the ramp is where we turn it off and where spark occurs. If you notice, some of these are not the same. We have some skinny ones here and some fatter ones. And what we need to do is we're going to retest this at the higher RPM. But let me scroll through. Look at that one right there. That one really shows it. So how is the coil going to fire if we have a ramp that is literally a fraction of the time of what it should be? I'm going to call this one to the right a good one, and I'll call that one to the left a bad one. So bad in that the coil is not being charged properly. What happens when we don't charge a coil? What's the result?
Really weak spark.
Really weak spark. And the reason we have really weak spark, that was perfect, Ryan. On film too, brother. Very good. We'll give Ryan props for that. Really weak spark because the magnetic field is really weak. So when the field collapses, the spark is weak. That number 2 cylinder is being affected by the charge rate of this coil. So it's not a coil problem, it's the coil charging. So it's a control issue. It would be either the module or the pickup, the input to the module, which would be the crank sensor signal, which is in the distributor. So let me scroll through this a little more and show you a couple more. The fat ones are the good ones. That's a bad one again, that skinny one. That spike at the top there is not a problem. That would be where the spark event occurs. And we are very near some plug wires with our amp probe. Again, weak spark. All right, we're gonna take this pattern one more time at the higher RPM. So go ahead and start that back up again. Can you hold the RPM up a little bit for me?
Yep.
All right, good. Shut it off. You can see it right in front of us here, guys. See the gap? What happens when we have a gap? So we have coil fires and all of these, right? The firing event, then what happened here?
No spark.
No spark. And what if that happened to be the same pattern every single time? What if that happened to be when the coil was supposed to fire the number 2 cylinder, that was when that event occurs? What do we see coming out of the cap and rotor? We see a missing spark. So we thought we had a cap rotor problem. We thought maybe we had a spark plug problem or wire problem, but guess what? We have a coil control issue, okay? Let me scroll through this a little bit. See the gap again? We almost see consistency there, don't we? So 1, 2, 3, 4, 5, 6, 7, and then we get that gap. There's one pattern there. Let's look at this gap. Look, 1, 2, 3, 4, 5, 6, 7. Same thing. We get a real fat coil charge before the dead one. That's the. Well, we're pretty sure that's the number 2. And look, it's consistent every single time. See it? See the consistency in that missing pattern? Every time that fires, we're gonna have no spark in that area. Scroll through this whole thing here for a second. And when we first started it, so in there, this will be an area that we didn't have necessarily that gap, right? See the fat one? Then see the charge of the coil? So what's this going to cause? This one over here is a no spark. What's that one? Weak spark. Very good. Very good. All right, next step. We need to look at the crank signal, and we'll look at the crank sensor signal the same time we're viewing this. So we'll pull in a second channel and we'll hook up to the distributor pickup. I'll show you guys how to do that. Before we show you guys the crank sensor, remember how this vehicle came in. It came in with what removed?
The wiring.
The spout connector was missing. We actually made this connector because we didn't have one, okay? The spout connector is the spark output. That's what it stands for. Can you unplug that for me, one of you guys? So I can't do it with one hand. Just get that thing out of there for a minute, if we can, with the zip tie there. I don't know if we can or not. Cool. Well, that hang out there. We can't leave it on the pulley, but we can kind of leave it chill back here in the back. All right, we're gonna redo this test with the spout connector unplugged. Do you remember what the owner said to us? He told us that the garage who looked at it that removed the spout told him that's what he needed to do because his computer was going bad. Remember, those were the words he used?
Yep.
Okay, start this back up. And let's look at this pattern again. Go ahead and kill that light. I want you guys to keep in mind, that this is now operating in base time mode. Okay? Do you see that we're very consistent here? And if we hold our RPM up, go ahead and do that a little bit. Grab the whole thing and hold it that way. Just go ahead. Just a little bit. Our misfire is totally gone. Okay, good. All right, kill it. Let's talk about what we're looking at here. Let's scroll through and let you guys see how consistent these are all the way through. Notice the gaps have changed. You guys see it? Don't worry about the upward spikes that are there on occasion, but you see how the dwell time on all of these is even and consistent? So our misfire, if we drive this right now, our misfire would be gone. Now the problem though, is we'd be running in base time mode all the time. No spark advance, but our misfire would be gone. All right, so just put that in the back of your minds for a minute. And that is why he was told to leave the spout unplugged, going after the crank sensor signal now. Quick tip on these Fords, on these TFI modules. The top wire on the module, which in our case is blue, that is your crank sensor signal wire. Ford calls it a PIP wire. PIP stands for Profile Ignition Pickup. On all of these systems, that top wire is your PIP wire. That's your crank sensor signal. That's the one we're connected to. We have the spout connector reconnected, and the setup on this is, let's run this live. Come down to channel 2. We'll display it, turn it on, and we want this to be, this should be a 0 to 10 volt Hall effect. So 20 volts would work. Time base, we can leave that alone. Our 0 line, I would just prefer to pull that down. And go ahead and start that. Let's see what this looks like. Again, our spout connector is reconnected. And what you'll notice is the issue with the coil dwell is there again. Can we hold the RPM up a little bit? Good. Let me look and make sure we caught it. I want to see some gaps. There's my gap. Cool. All right, that's good. Go ahead and shut it off. I don't know that I could explain this to you guys here as far as why and how. I can tell you what to look for, but can I tell you the exact cause of why these things do this? I'm not sure that I can. I will tell you that this is a consistent pattern failure with a faulty Hall effect in these distributors. What we're looking at, this crank sensor signal, which is the green trace. Let me show you the, I think this is something that I might need to actually pause, put on the board, and be able to draw and talk to you guys and show it to you up there. What we're looking at when this drops out, can you guys see the clip in the top of this waveform here? See the green trace with the clip in it? Hang on, let me save this. Make sure that I don't lose it. Save movie. Okay, and then just in case, do a save image too. Oh, so glad I saved that because I just lost it. Stupid. Start that back up again. Sorry, I lost that image. Shut it. All right, you're good. That ignition switch stuck there, didn't it? You hear the starter cranking?
That's what I was.
All right, hold the RPM up a little bit again. Okay, good. All right, we caught it. Okay, good. Kill it. All right, the crazy part about this is you see the clip in the crank sensor signal at the top, and then you see how much that one's clipped, and then you see the result of the dwell time after that, and then this one that occurs after that larger clipped event. That's what's causing this dwell to change the way it is. Let me show you the same picture now with the spout disconnected so you guys can get an idea of what I'm talking about the clipped signals, okay? So I'm unplugging the spout and then we'll retake this shot. Hold the RPM up. Okay, good. All right, kill it. Okay, what do you notice about the green trace now with the spout disconnected? The tops of the patterns are not clipped at all, okay? And you see how nice and consistent and uniform the coil ramps are, the yellow trace. The smaller square wave here is a sink notch for #1 cylinder for injection firing. So that's why that one's skinnier. Let me zoom out one more level so you can see that. What you'll see is every 8 will have a skinny one. So look at that one. Let me move over a little bit. So there's your skinny one right there, the green trace. There's your skinny one there. So count that as 1, 2, 3, 4, 5, 6, 7, 8, 1 again. That's one rotation of the distributor from there to there. Those are normal, but you see how consistent everything is? All right, so when these crank sensors fail, the clipping part of the top of that, which has to do with the spark timing, when the computer comes into play with the spout signal, that's what's messing this up. I'm not sure I can do it here with the camera in front of me and nothing to write on. Is there anything else I can show you before we maybe take this up to the board? I'm not sure. Let me just say this. When you see this pattern where, let me save this image too, hold on. When you guys see a pattern that looks like this, where the tops of these are all clipped off as much as they are, the tops of the waveforms, especially that one where you see like a really skinny one, so I'm talking about that guy right there. When you see that, these should be even and consistent and uniform, the top clips of this, which is the computer adjusting the ignition timing. When you see that, you have a faulty crank sensor. You need a distributor, okay? We'll definitely get some after pictures so I can prove to you what these look like, what they're supposed to look like. How many of these are you gonna see anyway? I don't know. But that's the issue, is a faulty Hall effect in this distributor that's causing incorrect dwell times and causing this coil issue, weak spark on one cylinder, misfiring. And it would actually affect multiple cylinders. We were seeing that when we did secondary waveforms. We were seeing it on 4 different cylinders at times. Very, very difficult to diagnose without a scope. The tip would be, if the vehicle runs good with the spout connector unplugged, okay, and runs bad with it plugged in, you need a crank sensor or distributor pickup. You follow? So I'll say that again for you guys in the future. If you run into one like this, if it runs bad, misfires, and it's had plugs and wires and, you know, everything else thrown at it and it's not fixed, if you unplug the spout connector and drive it and your misfire is gone, you need a crank sensor, which is the distributor pickup. Plug the spout in and your misfire comes back, right? That's what it is. All right, one last piece maybe we'll show is the spout signal in here with the crank, and maybe we can get a little bit more research as to why this does this. The how part, I showed you. The why is another subject. All right, for this next part, we broke out the Varus because I need a 3rd channel and the Vantage Pro doesn't have a 3rd channel. So we're using the Varus now. I gotta set everything back up. My channel 1 is going to be my Go 4 channel. Channel 1 is going to be my crank sensor signal. Well, not much I can do about the glare. We're just going to deal with it. I got to set my other channels up. So channel 1 is my crank signal. We'll set that back to 20. Channel 2 is going to be my spout signal, so we'll set that to 20 as well. Channel 3 is my amp probe on the 20 amp setting. That's my coil firing events. And we were on 50 milliseconds before, right?
Yep.
And that should be good for us to start this and run it. Let me make sure ground lead, everything else is good in the way. Okay, good. All right, start that. I'm gonna go, I don't know if this is gonna be helpful to go 50 volt and 20 amp, just so I can separate this stuff a little bit. Probably should change it back. Yeah, I don't think I like that. Where I like the Pico, because I can scale the Pico and stay on the same voltage trace and kind of shrink them so they're not all overlapping each other so much. And we'll have to pause that to really look at it. Can you hold the RPM up a little bit for me? Okay, cool. I saw what I needed to see. Can you go ahead and shut that off? See if I can explain this to you guys. I don't understand the workings of the electronics in this as much as maybe I should. It's a dead system and I really don't have to anymore. I guess what I'm saying is I know how to tell you where the fault is. I don't really know maybe the why part as much as I should. If you look at the blue trace, that's my coil ramps. And so remember, just same thing we saw on the Vantage was that real short one. Let's see if I can find it. Short or missing. So this one here, see the fat pulse here, and then you see the short one there. See if we can get another shot of that a little bit more pronounced. See the consistency in it too. See the fat pulse? See the fat pulse there, the coil ramp, and then right after the fat one we get that skinny one. It's consistent, and that would make sense. It is the number 2 that's affected the most, right? That's what we are seeing live. So our focus would be on this small event area where I put my cursor. And notice the clipping of the yellow trace is what I was trying to describe to you guys. See how that's clipped off? Do you notice that that's exactly in time with the spout signal? The spout is what we weren't looking at before, which is the green trace, okay? That signal is, if you read the material on the EEC-IV ignition systems, it says that the spout, the spark output, the way the computer controls timing, is it will actually clip the PIP signal. The yellow is the PIP. Let me make sure our terminology is right here. Yellow is the PIP or the crank sensor signal. PIP stands for profile ignition pickup. The spout, which stands for spark output, is my spark timing signal. So what we have is a PIP signal going into the engine computer. We have a spout signal coming out of the engine computer and talking to this module. So module sends the PIP from the crank signal, computer sends the spout. And to control timing, remember the module controls timing on this all the time. So that's why you can unplug the spout connector and still have spark. It just runs in a base mode without the computer. Once you plug the spout connector in, the computer starts to influence the module and tell it what to do with the spark. How to charge the coil, when to let it go. That's what the green trace is doing. And what you're looking at is the clipping of the PIP signal is being caused by the spout command. Okay? What that looks like internally, I can't tell you. I am not an electronic engineer. I'm just telling you to watch this. See the clipping mechanism here, and see the clip taking place here. You notice how they're different in time as far as how much we're clipping. This is a fault with the crank signal when you see this. Okay? It changes our dwell, it changes our timing, and that's exactly what we're looking at. We should see, and here's the key with this, the yellow trace, focus on the yellow. We should see consistent clipping in each of these, and we are not. Look at this one. Oh, it's completely missing, right? And then we see that short ramp after that. So just kind of focus on, look at how fat these ones are, the clip of those PIP signals, right? And then how skinny these ones are. You want to see uniform, even, consistent patterns. Guys, I'm telling you, the first time I did this, I looked at that and said, well, that's a computer problem, right? If it runs good with the spout connector unplugged, then that means the computer is causing this problem. Make sense? And so what did I do the first time I saw one of these? What do you think? I put a computer in it. And that was after putting plugs and wires, cap and rotor, and not fixing the vehicle. And the distributor, here's the thing, the distributor was new. So the first time I literally got my ass kicked by one of these, I put a computer in it. Guess what didn't fix it? The computer. And guess what we did? We put another distributor in it. And that was out of desperation. And it was then that I learned about these signals, that I need to start watching for them. And from that point on, again, I don't know if I'm making myself clear on these clip signals, probably because I have questions about it myself and how it's actually working. But I'm telling you, here's the key. You see uneven PIP clippings, you have a faulty crank sensor, which is the distributor pickup. Okay? The why part we can debate, and that'll be fun to do at a later time. You know, hearing all the comments will be fun to hear about why and why that happens and how this actually functions. But again, one more time, the other key is if you have a misfire, you can't get rid of on one of these Fords, and you unplug the spout connector and your misfire goes away. Once again, you have a faulty PIP signal, crank signal in the distributor. That will fix your problem. Okay? It's not a computer problem. It is the pickup. I don't know if we should look at this with the spout unplugged. Not sure that that would be helpful or not, but being that I'm showing this, maybe we will. But I'm definitely going to save this picture first. Okay, I unplugged the spout. I want to take this one more time with the spout unplugged. Go ahead and start that up. I don't even know if we'll have a spout signal at all. I moved the connector to the computer side of the spout. Alright, cool. So there is still a spout signal there. The blue trace is the spout. And that's with it disconnected. Hold the RPMs up a little bit for me. Okay, good. Kill it. Notice the clipping is not taking place at all on either the green or the yellow channel. And again, that's the part that I can't explain to you what's actually going on with those transistors. There's some information I'm sure we could research and plug all this data in, but look how, again, how consistent and uniform those blue coil current ramps are. Not breaking up at all, no misfiring at all. That's with the spout disconnected. Okay, start that back up. I'll let you guys watch live while I plug this spout back in. see the clipping start to take place here in a second. So when you plug the spout connector back in, you're initiating the module's communication with the engine computer, and now the module's listening to the engine computer on what to do. Why would a faulty crank sensor cause that? I don't have that answer for you. I guess the answer is I don't know. I'm just showing you what to look for. This is a faulty crank sensor. If I could show everyone's faces, I know that you're all just kind of taking my word for it. That's what you have to do, and we'll change the distributor, and I'll show you what this looks like when we're done. You can see those small ramps in the blue trace. Ed, you came over late. You see the small ramps in that blue trace are what's causing our miss. Raise the RPM one more time. We'll show Ed since he's standing here. I'll pause it. We'll let him see it. Looks a little bit better right now, doesn't it? Go a little bit higher. See how more even the yellow trace is looking right now too? Let off. A little bit higher, just a little bit. Where you can hear the miss.
Oh, that pick up?
Right about there. Having trouble seeing it now. All right, hold on. Why is this thing so slow right now? Okay, we caught it. All right, good. Shut it off. All right, so what you missed, Ed, is the number 2 cylinder is consistently misfiring, and what's happening, see the blue trace is the coil charging, turning on, turning off, turning on, turning off. Same coil every time. Notice in this area, see the ramp is missing, and so what you have is a weak event of that coil, and that's what's making this thing misfire. So, and if you put like we put a spark tester on, it actually physically shows the number 2 dropping out. You'd swear it was a cap and rotor problem. It is absolutely not.
It's amazing. It's actually a crank sensor.
Yeah, and what you look for, again, I'll say this last time, we'll end this, we'll put a new distributor in. See the gaps of the yellow trace. Right. See the clippings of the yellow trace. Do you see how it got inconsistent right there?
Right.
And then you see the result of that inconsistency is this blue trace. You see this?
Really
in fact, what you can look at, if you look at this, hang on, if you look at that one close, a little bit closer, what you'll notice is right where this clips off, okay, is the beginning of our dwell time. Can you see that? Yep. Like right in that area? And so we get this really fat pulse, and then the next one, who mentioned that? Jess, was that you that asked me about, or was that Ryan? You asked me about, was it this event, was that affecting the next event? And I think the answer is yes. That coil, we held it too long for this one, and it actually affected the next ramp. Like it almost, where this one should be turning on is where, see the clip right here? This is where the charged event should be occurring way over here. And you see how delayed it is? And do you see what caused it? What initiated it, what caused it was this yellow trace. Or you could look at the spout and you see the opposite occurring up there. So in any case, whatever the computer's doing with this transistor that's making the square wave or that signal, it shouldn't be clipping it off like that. That's what's affecting everything, and it's a faulty crank sensor. I'm sorry, I keep coming back to trying a better explanation and hitting it from a different angle, and I don't have one. But there it is right there. Uneven gaps in your PIP, and I guess you could say your spout. You need a crank sensor, which is the PIP signal, which is the sensor in the distributor. The pickup is bad in the distributor. We're gonna put a new one in, we'll get some after pictures, and maybe I'll try one more time. I don't know, we'll see.